Ladies and gentlemen, we're going to take a look at our second transformation unit or lesson, and that's lesson 5.7. This is page 130. So page 130 in your note-taking guide, and we're going to take a look at what are called reflections and symmetry. Today we're going to primarily focus on the reflections. Tomorrow in class, I want to together take a look at lines of symmetry. So we're going to identify and use reflections, and then, like I said, we're also going to talk about our lines of symmetry. So let's take a look at our vocab. A reflection is a transformation that creates a mirror image. So we've talked about these transformations. It maps another object onto an image, and so we have this mirror image. The figure is reflected over a line called the line of reflection. So we're going to have some sort of a line of reflection we're reflected over. For reflections, we have to remember we're looking at opposites. So they're going to be facing opposite directions. The same shape, they're just facing each other. They're in opposite directions. The line of symmetry, and this is kind of why I wanted to be able to look at this tomorrow with you. It's a line within a figure that the figure can be reflected over to map on itself. So we talk about a square has a line of symmetry. So down this middle, I could reflect the right-hand side over onto the left-hand side, and it would create the square itself. I don't have an object that looks different. It's just another square. So we'll take a look at those tomorrow. So let's take a look at our first thing. We're going to look at the properties of reflections, what has to be true. The reflected image is going to be congruent to the original figure. So the size and the shape doesn't change. They're still the same size, the same shape. The orientation, though, the direction of the reflected image is reversed. I use the word opposite in the definition. It's reversed. And the line of reflection is the perpendicular bisector. I'm going to go off the line here. Of the segments joining the corresponding parts. And as we look at that, we have corresponding parts that we've connected, corresponding parts that we've connected, corresponding parts that we've reflected. And then we have this line of reflection that hits each of those red segments I drew at a 90-degree angle and hits them at the midpoint. So there are additional things that we can study with this in geometry. But this is what it means to have a line of reflection. You have something down the middle, and we have the image that we reflected over. Notice they're both pointing with that narrow vertex at the top of the reflection line. All right, so your follow-up. You want to draw the reflection of the letter E in the line K, or I usually say in class, over the line K. So I need to reflect this over, so that means the orientation is going to be reversed. If I'm facing to the right, my image is going to be facing to the left. So I'm going to have an E. I'm going to face to the left. I'm going to let you do this one on your own. And we will check in class. I do want to do on this second one, we have to reflect it over. So the top, this part would now be the bottom. We then have our middle, would be in our middle. And then our bottom is up here at the top. And so even though it's going to look like the exact same shape, if we were to color code that, we can now see that the two green segments are equidistant from line K. My two blue segments are equidistant, and then the red ones are equidistant. All right, so we want to identify a reflection. So we want to tell whether the gray image is a reflection of the black image. So is this top gray one a reflection of the black one? This bottom one is a black one. It's hard to tell from the video, but you should be able to tell in your notes. But if you look, you're supposed to see are all three properties of reflections met. Is the image in A congruent to the original figure? Yes. Is the orientation reversed? Why, yes. I've got this long flat side close to the reflection line, long flat side close to the reflection line. And is the line connecting the corresponding parts, the perpendicular perpendicular line segment? Yes. And so because of that, the gray triangle is a reflection of the black triangle because all three properties are true. So if we look at B, if we look and see, this is our black image, our original, the gray one's the image on the left. Is the image congruent? Yes. But is the orientation of the image reversed? Well, no. This flat, straight side is on the left-hand side. So for this one, it's not reversed. Is the line a perpendicular bisector? Well, no, it's not a perpendicular bisector connecting them. This side is closer to my line of reflection than this side, so it can't be a perpendicular bisector. So the answer is no, because it only meets one property, that congruence property. And that's going to be true for both the translations that we studied yesterday and the reflections we studied today. So that leaves us with our follow-up. Name the transformation shown. I kind of just did that because if we look at this split screen, all we did in part B was move it over. It slid over. So this is what we call a translation. That was our transformation from yesterday in lesson 3.7. All right. Now we want to take a look at reflections in the coordinate plane. So which segment is the reflection of AB in the x-axis? So here's AB. This is the one we're looking at. And we want to reflect it over the x-axis. So here's the x-axis. Well, if I look at this, A is 1 unit above the x-axis. I need to pick the segment that is also 1 unit above the x-axis. And so when we look at that, I need B to be 3 units above the x-axis. And so this one is 3 units. So JK, sorry guys. So JK is the reflection of that. A would reflect onto J. So A becomes J, which is -4, -1. And B reflects onto K. And so K it's going to be this -1, -3. For B, we want to know which one is the reflection of it over the y-axis. So I need to focus on this y-axis here. And so when I look at reflecting over it, it reverses over. So this was 1 unit from the y-axis. I need whatever is 1 unit from the y-axis over on that other side. So when we look at that, the segment that is the reflection is DE. A is reflected to D. So D has the coordinates of +4, 1. And B is reflected to E, and E has the coordinates of 1, 3. If you notice, guys, when we reflected over the x-axis, the x coordinates stayed the same, and the y coordinates became opposites. When we reflected over the y-axis, our y coordinates stayed the same, and the x coordinates became the opposite. And that's going to be true for every reflection over the x and y coordinate. Okay, guys, sorry about that. We're going to have our checkpoints here. You're going to tell me whether it is a reflection or not, and then tell the line of symmetry. So I'm going to do the first one with you. If we look at it, this is the black image. This is the one that they want me to look at. So is it a reflection? And so if I look, this is 1 unit. This is 1 unit away. This is 1, 2, 3 units. This is 1, 2, 3 units away. It's the same length, so it's holding congruency. It's opposite orientation. Our if they're going in opposite directions. One's negative, one's positive. So they're holding those two. And we've got this idea of this perpendicular bisector. And so this would be, yes, it is a reflection. Well, what did I reflect it over? Well, I'm reflecting it over this line. This is where what was separating us. So we would say the x-axis was our line of reflection. So I want you to do 2 and 3. You're going to do now, and then we will check in class. I will call you up to go over those. If you look, we still have 2 more left. We have example 3 and example 4. I want to do those together with you in class so we can be drawing lines of symmetry. I want to make sure that you've done that and see a little bit of that with you. So we'll bring our book back to class tomorrow and finish those up. So that's it for tonight. Go back and finish your follow-up and checkpoint.